Assalamu alaikum everyone. Welcome to IIT Learning Hub. I'm Dr. Mohammad Suleiman Memon, and in today's lecture we are going to start one of the most important concepts in C++ programming, object-oriented programming, commonly known as OOP. This is a complete beginner-friendly lecture. We will understand classes, objects, and the four major pillars of object-oriented programming. So stay with me until the end because we will also examine a simple C++ class, create an object, and finish with a practical exercise. Let's begin. By the end of this lecture, you should be able to compare procedural programming with object-oriented programming, explain the basic idea of object-oriented programming, identify classes and objects, and distinguish attributes from methods. You will also learn the four pillars of object-oriented programming and write a simple C++ class. These learning outcomes are important because they provide the foundation for our upcoming lectures on constructors, inheritance, polymorphism, and advanced object-oriented design. Before learning object-oriented programming, think about what we have already studied in C++. We have used variables to store data and operators to perform calculations, loops to repeat statements, functions to organize code, and arrays to store multiple values. Now we are moving to a new level of programming. Object-oriented programming helps us organize larger programs in a more logical and manageable way. OOP is widely used in modern software development, so understanding this concept is essential for every programming student. First, what is a programming paradigm? A programming paradigm is simply a style or approach used to solve programming problems. Different paradigms organize programs in different ways. Procedural programming focuses mainly on procedures and functions, while object-oriented programming focuses on objects. Functional programming emphasizes functions and expressions, while logic programming uses facts and rules. In this lecture, our complete focus is on object-oriented programming. Object-oriented programming is a programming methodology that organizes software around objects instead of only around functions. An object combines data and the function that operate on that data. OOP also helps us model software using real-world entities. In procedural programming, we may ask what function do we need. In object-oriented programming, we first ask what objects exist in our system. This change in thinking is very important. Let's look at the real-world example. That is basically a car example. A car has properties or state. Its color may be white, its model may be a Corolla, its speed may be 60 kilometers per hour, and it has a particular brand. At the same time, a car has behaviors or actions. what the car can do. It can start, it can stop, it can accelerate, and it can do a brake. So in OOP, we can model the car as an object containing both its data, that is basically color, model, speed, brand, etc., and its behaviors, that is basically start, stop, accelerate, brake. These are the different actions. Remember the simple idea: an object contains state plus behavior. Now we go for another example, that is basically the student. And considering this example, just see there are the different properties of a student, the student name, roll number, department, age. And every student will have these properties. And we talk about the functions or the behaviors and actions of a student. Every student will study, and every student will attend the class, and every student will have to submit the assignment. So objects have data plus behavior. A car and student, mobile phone, and laptop can all be the modeled as objects. Data describe the state of an object, while the functions describe the behavior of an object. So OOP combines state and objects into one logical unit. This makes the program easier to understand because related information and related operations are kept together. So now question arises, why do we need object-oriented programming? Imagine a very large procedural program containing hundreds of functions and thousands of lines of code. As the program grows, duplicate code may increase, and the maintenance becomes very difficult. And at the same time, the debugging is also very harder, and the software scalability becomes a serious challenge if you want to extend the software or if you want to increase the software in future. So the procedural programming is not bad, but for many large software systems, we need a better organizational approach. Who provides that structure? So how OOP helps? Object-oriented programming is one of the most impressive approach that helps through providing the reusability, modularity, data security, easy maintenance, real-world modeling, and scalable software design. So the reusability means we can reuse the existing code, and modularity means we divide a large system into logical components. This also is very easy to understand. And the data security allows us to control access to data, what can be accessed or what should be restricted. So these advantages are major reasons why OOP is widely used in professional software development. Now we come to an object. An object is a real world or a software entity, and every object can have identity, state, and behavior. For example, a particular student has an identity. The student's name and age represent a state. Activities such as reading or writing represent behavior. In programming, an object is an actual instance that we create from a class. So the student object, let's examine student object. The state may include name of the student, age and roll number, and the behaviors the student can perform may include student can read, student can write, and student can sleep. So in C++, the state is usually represented using data members or attributes, while behavior is represented using member functions or methods. Keep these two terms in mind. The data members represent data and the member functions represent operations. Now we come to the class. What is a class? A class is a blueprint or template used to create objects. The class defines the data and functions that its objects will have. One class can create many objects. Think about a house blueprint. A single blueprint can be used to build multiple houses. So in the same way, one student class can be used to create a student 1, student 2, student 3, and so on. Now just see this slide for classes and objects. This is a conceptual diagram. The diagram shows the relationship between a class and objects. At the top, we have the student class. It defines properties such as name, age, and department, and behaviors such as study, sleep, and submit. From this single class, we can create multiple objects: student 1, student 2, and student 3. The class defines the structure, while each object represents an actual instance of that structure. So let's compare a class and object. A class is a blueprint or template. It defines data and functions, and one class can create many objects. An object, however, is a real instance of a class. An object occupies memory and represents an actual entity in the program. Different objects created from the same class can hold different data. For example, Ali and Ahmed can both be student objects that have different names and ages. So this is our first program, how we are going to write our first C++ class. So let's do the code in the dev C++, and we are creating a new file, hash include iostream, and then using the above one is the header file, using namespace std. Now we write a class, and the name of the class is let's say student, and we define the access specifier. We write a public, and here we define the different data members. Let's say string name, and there is another data member that is actually integer age. Now what we do, we create a function. Currently we write a function and we name it as a display function to display the details, and we have defined void because this function will not return anything. So in later section we will define what's the difference between void and the other things, or we can return anything from the function. So now what we do here, we print cout name, and we say it's a name, then end of line, and then cout and age, this age data member, and end of line. So we are done with this. Now let's say we create this as a first class program .cpp. Now what we do here, since we have created the class, data members and the functions, so now we create a main function, integer main, and here we create an object. So before creating an object, you have to specify the name of the class, that is a student. Now we specify s1 as the object name. Now with s1 we can access the data members or the functions from the class. So s1 dot we'll find s1 here. S1 dot name is equals to Ali, and s1 dot age is equals to, let's say, 23, and now we want to actually display, so we'll write s1 dot display. Now let's compile this. Here is the one mistake. We actually have done a mistake. It's a public. Now let's execute. It says that because integer, we have specified in double quotes. Hope so this works. There are no errors and warnings. Now let's run this. You can see that the output has been displayed. Name is Ali and age is 23. Now since we have created this class, now we can create many objects. This is object 1, and now we can create another object like student, then s2. This one is another object, so s2 dot name is equals to Riaz, and s2 dot age is let's say 22. Sorry, it's integer, and now s2 dot display. So it should display the details of another student as well. So let us compile it again and execute. Now you can see that the data of 2 students has been displayed. So one is Ali and another is Riaz. So in this way you can actually create the class and objects. Now What have you understood from this program? First, you need to create a class, the named student. Then we actually defined the data members, which it contains the name and age. And then there is a method, we can say a function. We created a display function, which actually returns nothing. And then there is a one object, that is student s1, and the dot operator is actually needed to access the data members or the functions which are publicly accessible. So this is the memory representation. Now look at the memory representation. The student class defines the structure, name, age, and display. When we create S1 and S2, each object gets its own data. The first object may store Ali and age. The second object may store the Riaz and the age. So both objects use the same class definition, but their data values are independent. This is a very important characteristic of objects. So creating multiple objects. We can create multiple objects from the same class. Here S1, S2 are of the two objects of the student class. Each object has its own data. We assign Ali to S1 and Riyaz to S2. The class is written once, but we can create as many objects as our program requires. So this demonstrates the reusable nature of a class. Now we come to the four major pillars of object-oriented programming. Now we reach to this slide, which is very important. The four major pillars of object-oriented programming are encapsulation, inheritance, polymorphism, and abstraction. These four concepts form the foundation of OOP. In today's lecture, I will introduce each concept in simple terms. In upcoming lecture, we will study them in much greater depth and write practical C++ program for each one. So we come to the encapsulation. The first pillar is encapsulation. Encapsulation means building data and functions together into a single unit. It also helps protect data by controlling access. A class is a basic mechanism for encapsulation. A simple real-life analogy is a medicine capsule, which contains different ingredients together inside one capsule. Similarly, a class keeps related data and functions together. Now we come to the inheritance. The second pillar is inheritance. Inheritance allows a child class to acquire features of a parent class. Its major benefit is code reuse. For example, imagine an animal class, then a dog class, and then a German Shepherd class. A more specialized class can reuse characteristics defined in a more general class. We will later learn base classes, derived classes, and different types of inheritance in C++. Now we come to the polymorphism. The third pillar is polymorphism. The word polymorphism means many forms or sometimes many shapes. In programming, it means one interface or operation can have different forms of behavior. For example, consider a draw function. A circle may draw itself in a one way, while a rectangle draws itself differently. The operation is conceptually the same, but the behavior changes according to the object. Later, we will study function overloading and overriding in relation to polymorphism. Now we come to the abstraction. The fourth pillar is abstraction. Abstraction means hiding unnecessary implementation details and showing only essential features to the user. Think about driving a car. You press the accelerator to increase the speed, but you do not need to understand every internal engine operation. The complex implementation is hidden. So, same is with the software. Abstraction allows users or programmers to interact with a simple interface without dealing with all internal details. So there is a OOP concept summary. Here is a quick conceptual summary. We start with the objects and classes. A class defines the structure and objects are instances. Encapsulation, groups, data and functions. Inheritance supports reuse between related classes. Polymorphism allows the different forms of behavior. Abstraction hides unnecessary details. These concepts are connected and together help us design organized object-oriented software. So we come to the some real-life applications of object-oriented programming. Object-oriented programming is used in ATM and banking system. It is used in hospital management systems, social media applications, messaging applications, online shopping systems, games and desktop software. In such systems, entities such as customer, account, patient, doctor, product, message, or player can be represented as objects. This makes software design closer to the real world problem. Now we come to the advantages of object-oriented programming. It makes the program easier to understand and organize, and maintaining the code becomes very easy, and the code can be reused many times. We can improve data security through controlled access. Object-oriented supports modular programming and can speed up development of large projects. It also helps debugging and supports scalable software design. These benefits become especially important as software systems grow. But at the same time, there are some disadvantages, so we have to discuss them. It can initially feel slightly complex for beginners because you need to understand classes, objects, and the relationship. So, good object-oriented programming program requires proper software design. OOP may use more memory than a very simple procedural programming program, and small programs may not need a complete OOP design. Therefore, we should choose a programming approach according to the problem we are solving. It is time for a quick self-check. So there is a question 1. OOP stands for, option A is object-oriented programming, and the option B is online object program, and option C is operating system, and option D is object-oriented optimization program. Of course, the correct answer is A, object-oriented programming. Now there is a question 2. A blueprint used to create objects is called function, class, variable, structure. The correct answer is class. And the question 3, an object contains only variables, only functions, data and methods, only loops. As we know, it contains data and methods, so option C is the correct answer. Which is not in a OOP pillar: inheritance, encapsulation, polymorphism, compilation. As we know, inheritance, encapsulation, polymorphism are all the pillars of OOP, but compilation is not. So the correct answer is D. Compilation is not the player. How many male players are there? There are basically 4. So the correct option is C. So here is the practical exercise which you should do. Create a class named car and define some data members like the brand, model, color, speed, and also define the member functions. Cars should start, should stop, and display, and create 2 objects. There should be Toyota car and the Honda car. Assign different values to both objects. Display the details of each car. So here's the lecture summary. We covered the programming paradigm and the introduction to OOP, objects and classes, attributes and methods, class versus object, creating objects in C++, and the 4 pillars of OOP, and advantages and disadvantages of OOP. We'll be covering the next lecture, class and objects in C++ in greater depth, and we'll cover the specifier, we'll cover the constructors, object initialization, and a more practical C++ examples. Thank you for watching this lecture, and I would like all of you to like, share, and subscribe the channel for more detailed lectures in future. Thank you.